Hello there, guys. We're going to have another experiment for you guys. We're going to talk a little bit about some factors that help determine whether something floats today. And then we have a nice little challenge for you guys at home to do as well. So, we're going to talk about our first factor here, and quick introductions. My name is Mr. Maddox.
My name is Mr. Dilworth.
Alrighty, and so we're going to talk a little bit about, well, I guess you'll find out.
Today, we're going to be talking about buoyancy and density, but specifically we're going to talk about buoyancy first. Now, buoyancy is the property of a fluid that can exert an upward force against a partially or wholly submerged body. So in other words, let's take this duck for example. This big inflatable duck here is not quite sunk down all the way, right? Normally when we think of inflatables on water, they're always floating pretty well like this. Well, that is because our inflatable here is very buoyant. It is able to stay on top of the water because that buoyant force is stronger than our gravitational pull towards Earth, and so it's able to keep our dear duck here afloat on top of the water. Now, I do have a joke, and Mr. Maddox, you might be able to figure this joke out, but do you know how to tell the difference between a male ant and a female ant?
No, how do you tell the difference?
Well, what you do is you get yourself a cup of water, right, and a couple ants, and if you put the ant into the water, and if it sinks, girl ant. If that ant floats, boy ant. Buoyancy.
Funny.
I know, I got a million of them.
Before you disappear,
Oh.
I do have some metal spheres here. I want to give you this one. So we have a small metal sphere and a large metal sphere.
Okay.
And I would like to ask you guys at home, which one of these do you think is going to float? Or which one's going to sink? So, I will tell you, one will float and one will sink. So go ahead and take your guesses. So, we're going to go ahead and drop these in. If you want to come a little bit closer there so you can get a good view inside of our nice blue bin. Alright. Can I count us down, Mr. Dilworth?
Sure. In 3, 2, 1.
Oh. So, the size of an object doesn't necessarily determine whether it floats or sinks. And so, our second factor that helps determine whether things can float on water is going to be density. And so, what is density? Well, density is basically how close all of those atoms inside of a substance are. Or you can think of it as the amount of mass per unit of space, or volume. And so, we are particularly interested in the density of water here today for our challenge. And so, we have a little cube right here. This is a 1 by 1 by 1 cube, 1 centimeter. So 1 centimeter length, 1 centimeter width, 1 centimeter height, which is 1 cubic centimeter. So water here has a density of 1 gram per cubic centimeter. So that means every cubic centimeter of water you have, that would have a mass of 1 gram. And so, if we are going to be looking at density, it probably helps to know what the formula is. And we have a very simple formula. You take the mass of that object and you divide it by the amount of space it's occupying, its volume, and that will give you the density in a unit that we will say grams per cubic centimeter. So we have a couple of things here to look at, and if you'll help me with this one, Mr. Dilworth.
Oh, yes.
We have,
Get this guy
oh yeah, get that out of there.
All right.
Go ahead and grab yours there. So, we have 2 bowling balls here. They are the exact same volume. But I care to wager if we put these in the water, something different might happen to each one. So I'm going to go ahead and set mine in the water. And you can be guessing right now, is it going to float or is it going to sink? So I'm going to go ahead and drop it. Well, I'm going to set it gently. Don't want to drop anything in here.
I'm pretty sure, yeah, that's what I was expecting to happen.
Yeah,
Mr.
it's a
Maddox.
bowling ball, right?
Right.
It sinks.
Which means this is going to sink.
Yeah, I mean, there's only one way to find out.
I agree.
So I'm going to go ahead and take mine out to make room for yours. Alrighty.
Okay. So we saw that one sink. This is the same size. It's still a bowling ball. I think it's pretty well going to sink as well. So let's see. Oh. Well, hopefully you can see that on camera that actually there is some space up underneath here, and this bowling ball is actually floating, so I was completely wrong. And why is that, Mr. Maddox?
Well, let's take a look into the density of these two bowling balls, and maybe, just maybe, we'll find our answer there. So, I'll go in ahead and I will tell you, we have an 11-pound bowling ball, that's the one Mr. Dilworth had, and I had a 15-pound bowling ball. And so an 11-pound bowling ball has a mass of 4,990 grams, and the 15-pound ball has a mass of 6,803 grams. And both of them have the exact same amount of volume here, so 5,540 cubic centimeters. So they're the same size, but their mass is different. So if we remember our formula from before, we're going to take the mass of our 11-pound bowling ball, and we're going to divide it by its volume. So 4,990 divided by 5,540. We get a nice answer. It's going to be not very pretty, so we're going to round it to the hundredth place for clarity. And we get a density of 0.92 grams per cubic centimeter. That means for every cubic centimeter of this bowling ball you had, it would weigh 0.92 grams. Now for our 15-pound bowling ball, we have a mass of 6,803, and then we have our same volume of 5,540. We divide those, and we get 1.23 grams per cubic centimeter. So now, if we know water has a mass of, a density of 1 gram per cubic centimeter, is 0.92 more or less than that? What do you think, Mr. Dilworth?
That's definitely more, Mr. Maddox.
No, not more,
Oh,
not
come
more.
on, but it's got
See
the
zero
9.
right here?
Ah.
So, our 11-pound bowling ball is less dense than water. So if something is less dense than water, it's going to float on top of it. And if you have something like our 15-pound ball here that is more dense than water, well then that is going to be something that sinks. And so maybe we can relate it to a real-life example. Maybe we can even relate it to our challenge that we're going to have. So, we all know what a cruise ship is. Maybe you recognize this one if anyone's a fan of the Titanic out there. We have a ship here, and as you want your ship to do, it is floating. And so that means that it is currently less dense than water, that it is able to float. Now, we all know what happened to the Titanic. It was driving along.
Yeah, we had two characters right here on the front.
Oh,
right?
yeah. King of the world,
Yeah,
right? King of the world.
and eventually they ended up on the door floating in the water.
Yeah, so how did they get on that door? Well, at some point in the journey, Titanic scraped against an iceberg and it started to take on water. So that means our ship here was filling up with water. And if we look at our formula again, if it's filling up with water, we're not changing the shape of the ship. The ship is the same shape, ship shape. And so, what we are doing is we're increasing the mass now. So if we are making our mass larger, but we're keeping our volume the same, we are making the ship more dense until eventually it gets so dense, so full of that water, that it is eventually going to sink. And so, today, for your challenge, we are going to challenge you to create some foil boats at home. And what makes it a challenge is we want to see how many objects you guys can, stack inside of it before it sinks, how much mass you can add. And so for today, we're going to use a sheet of foil. If you do not have pre-cut sheets of foil, cut them yourself, but do try to make them the exact same size, and also be careful if you're using scissors. And we're going to use pennies. So if you have a bunch of pennies lying around the house, these work great. If you don't, you can use Legos, you can use pebbles from outside, just any kind of small object that you can kind of stack in there to get some mass. So we're going to take our foil sheets, and your goal is to design a boat. And so we kind of have several. I'm going to go ahead and show us our first one here. Kind of went with a classic paper boat design. And so what I'm going to do is I'm going to set this boat in the water. And the first thing is to make sure it actually floats, which this boat is having some issues. It's a little lopsided. Maybe I can fix it. Alrighty. So I already notice that it's taking on water. So that probably is a good indication that it's time to redesign. So as much as I enjoyed this classic example of a boat, it's just not quite working for us.
Do you get holes in the bottom of your boat? Is your boat made out of tin foil? Then maybe these designs might work out a little better for you.
So these ones look a little bit more like something maybe you'd find in nature. Think of our lily gardens or things of that nature. And so now we're going to take one of these boats, and the very first thing is after you redesign is, okay, it's on the water. Do you see any water filling up?
No, I guarantee it won't fill up with water, at least until you put pennies in it.
Excellent. Well then, that's the first half of the battle right there, is we get it to float without taking on water. So now what we're going to do is we're going to take some of those pennies here, and now we're going to add them one at a time until it starts sinking. When it starts sinking, that's where you need to quit adding pennies. And so if I'm adding 10 pennies and it sinks at 11, did I successfully hold 11 pennies?
Yeah, man.
No, I didn't. It started to sink at 11. So be honest with yourselves here. And you're just going to stack them until it sinks. And so I'm going to let you decide the best way to stack them. I think what you guys will learn doing that will probably help you out a lot. But I guess our challenge is if you can get more than 70 pennies or 70 pebbles or 70, I don't know, nuts and bolts, whatever you happen to have lying around the house.
Yeah, so long as they're around the same weight and around the same size, you should be pretty well off.
Alrighty, so I hope you guys have good luck, and we'll hopefully see you in our next video.
Yeah, stay healthy out there.
Bye-bye, guys.
Bye.